Hello again, class. We are back to section 5-6. Last time we talked about this concept right here. Example 1 was about finding possible rational zeros. Let's just do that real quick. You're looking at leading coefficient and constant. Remember, the factors of the constant go on top. Factors of leading coefficient go on the bottom. So factors of this constant is 1, 2, and 4. Factors of the leading coefficient is 1 and 2. Remember the pluses and minuses here. Okay, the final answer will be all the possibilities. 1 over 1, which is plus or minus 1. 1 over 2, plus or minus 1 half. So on, so on. 2 over 1, so which is 2. Next, 2 over 2, which is 1, which is already covered. And next, 4 over 1, which is plus or minus 4, comma, 4 over 2, which is 2, which is already covered. So this list right here is the list of your possible rational zeros. Just possibilities. We're going to use that today in finding, basically what we're going to do today is we're going to find all the zeros of the function. We're not just going to look at possibilities, we're going to find all of them. So here's what I want you to do. Go to your calculators and type in this function that you see in my calculator. 2x cubed plus or minus 5x squared minus 11x plus 14. Take a moment to do that. Now, let's look at the graph of this thing right here. Okay, everybody should have a graph looking like that. You could change your window if you want to make it look nicer. Since I know my x values go from here to here, I could change my window to like x min -4 and x max maybe +4, and you can just change it up. And now it looks kind of cleaner, and you can find some zeros. You all know that there's a 0 here, there's a 0 here, there's a 0 here. Let's go find those. Well, over here I said number 1, how to find zeros of a function. Number 1, the first thing I always look at is I look at the table that makes life easy. So let's go to our table, see if we can get any of these. So second table, and there we go. Zeros occur when y is 0 and x in this case is -2. You look for y equals 0. So 1, 2 of them. You could keep scrolling up and down, but you're not going to find any more besides those 2. So here's a 0, -2. Here's a 0, +1. So you'd write those down. -2 is a 0 and +1. Here's my zeros so far, okay, of my function. Now, did you notice my degree of this function? Let's go back to the y equals button. Notice it's to the 3rd degree, so I should have one more 0 coming, but that's not shown in the table. So that's where you go to step 2. Use the calculate button in your calculator to find the zeros that are not integers. So let's go back to my graph, and what you found was -2. There's a 0. There's +1. There's a 0. And this one right here is not an integer. So let's go find it. And you've done this before, so remember this, the calc key. So second calc, we want to find a 0, so number 2. And you decide which one to find. So let's find this so we can type in numbers. We have to make a left-hand boundary. Remember, to the left of this point. Anywhere to the left, well, you don't want to go past here though, it'll be confused. So go right to the left of this point, which is right here or right here. So this point right here is what? Here's 0, here's 1, here's 2, so type in 2, enter, and then you type in a right boundary. So right after this point that we're looking for is what? Here's 2, 3, here's 4 right here. So I'm going to type in 4. And it says guess. Yes, you want to guess. So press enter. And there we go. The 0, it occurs at 3.5. Now you always change your zeros to fractions if you can. So 3.5 is the same as 7/2. You can type that in your calculator if you want. Okay, so 1, 2, 3 zeros, and the degree was 3 as well. So we're done. We found all the zeros just based on number 1, looking at the table, and then based on number 2, using the calculate button. But I'm going to give you some ones today where you can't just use these two methods right here. You're going to have to take it a step farther. So why don't we try one like that. Okay, here's the key concept of today. Now, this can be tricky. It gets hard sometimes, so just pay attention and try to do as best you can. How do you find zeros when it's a complicated expression, which I'm going to give you? Number 1, list all possible rational zeros. Sometimes we have to do this, sometimes we don't, but just keep this in mind. List the possibilities. Then what we're going to do, step 2, is we're going to use the calculate button in your calculator to find the zeros from this list. So we're going to do that, and then we're going to use those zeros to divide the polynomial synthetically, and then which will lead us to factors, which then will lead us to more zeros. And then we keep repeating steps 1 and 2, calculating until we get down to a quadratic. Then we can use quadratic formula to solve the rest. But keep in mind what we're doing. We're finding zeros. So factors will lead us to zeros. Okay, so let's you should probably pause the video, maybe take these notes down right here, and then we'll do a problem. So I'll move on to the problem. Okay, so put this in your calculator right here. This will be our example. 2x to the 4th power plus 5x to the 3rd power minus 18x squared minus 19x plus 42. Put that in your y equals button right now. So I already put it in mine. I didn't clear my first one. I just put it in y2. You can do whatever you want. So mine's in y2 right now. Okay. Now what we want to do with this is find zeros. And I told you before you could look at your table. I always look at my table first. So let's do that. Let's not make it harder than it is. Okay, so let's look at the graph. Look at that graph right there. Look how many times it crosses the x-axis. 1, 2, 3, 4 times. What degree is it? Notice it's to the 4th power. That's no coincidence. Okay. Now let's look at our table. See if we can get anything out of our table. Notice one thing in there. You see -2, 0. So off to the side to myself, I would write x equals -2 is a 0 of the function. Okay, that's what I got from my table. Sometimes you'll be able to get one thing or two things, sometimes you won't. So be ready for that. But since that is a 0, what does that lead me to? We talked about this the other day. Then, if that's true, then x plus 2 is a factor. So think about this. Here's the function. X plus 2 is a factor of this function. Okay, so we got one factor down. It's to the 4th power, so probably got 3 more, but maybe not. Alright, so since we know that's a factor of this, just like you did the other day, you're going to divide. So put the -2 in the box, because that's put your 0 in the box, and then let's do the work. 2, 5, -18, -19, 42, 2, -4, 1, -2, add them up, -20, +40, and what is that? +21. Excuse me. And then -42. And notice you get a 0 there. This is how you can tell that this is a factor, because we got a 0 here. That's going to be important in this lesson. Okay, so -2 is what we call a 0. We saw that in our table. Now let's go get some other zeros. That's the only one in your table, as you can see as you flip through. But now we're left with this, what we did was we just used a 0 to come up with another factor. Keep that in mind. So what is our factor? Now we have my notes off to the side. We got 2x cubed plus x minus 20. Oh goodness. Let's see. 2x cubed plus x squared minus 20x plus 21. That's what this is right there. Okay? Now, so basically x plus 2 times this gives you the original. Let's find a 0 within this guy. That's the next step. What we could do if we went back to my notes is you could list all your possible rational zeros. But if you look at your graph, let's see. Here's all the zeros. 1, 2, 3, 4 of them. These could be rational numbers or not. Right now we know -2 right here is one of the zeros. We don't know what this is. We don't know what these two are. So we are going to go to, I think, step 2, and we're going to calculate one of them. Let's calculate. Calculate a 0, and you can choose anyone. Let's go for this one. See my cursor, how it's blinking? I can move that cursor up and down, okay, the whole way across. Now, let's say I'm going for this point right in here. Okay, there's 2 of them, right? Let's say I'm going for that one. I have to make a left boundary, so that's, see my cursor down? It's to the left of the point. I want this point right here. See how my cursor's to the left? Just hit enter. You don't even have to type numbers in. Make a right boundary, so I'm going to take my cursor and I'm going to move it up a little bit. See how I'm to the right of the point that I want? I'm going to hit enter. Gonna guess, hit enter again, and it's going to give me, look at that number, okay, 1.8284271. That's an ugly number, but maybe off in your notes somewhere you might write that 1.828 and then ... It doesn't have a pattern to it. So what that's telling me right there is that number is probably irrational. So you're not going to be able to tell me, hey, here's the answer. That number's irrational. Okay? So what you want to do is you want to go get another one. So maybe you want to go get this 0 right here. So second, calculate, number 2, and then I'm going to move my cursor again. I want a left boundary of this one, so I'm going to move to the left here. Right now my cursor's to the left of that point that I want. I'm going to press enter. You can scroll to the right of the point you want. Be careful, don't go past the other point. So I'm right to the right of it right now. Hit enter again. And let's look at this number. Ooh, look at that number. A 0, 1.5, 0. Well, that's a nice number, isn't it? So my zeros so far, the given was what? -2 is the given. And I just got one. 1.5, but instead of 1.5, give me 3/2. Okay? Now, since you found that 0 right there, what does that lead you to? You should be thinking, oh, well, if that's a 0, then x minus 3/2 is a factor. So here's what you're going to do. You're going to go use synthetic division to find another factor. So one factor is x plus 2, and we found another 0, which leads us to another factor, which, let's go back to synthetic division. In the box, you put the r, which is 3/2. Okay? Now this one, it's going to take a little more brain power. 3/2 into, now check out what I'm going to write right here. I'm not going to write the original. I'm going to write the last factor. I'm putting that here. So see how complicated this is kind of getting? So you have to be very organized with your notes and what you're doing here and know exactly what you're doing. So you find a 0, you put it here, here's a factor. There it is. Within this factor, are more factors. So that's what we're doing. This is a 0 of this factor. Okay, this is a 0 of this factor. So that's why I'm going to put 3 halves, and I'm going to use this up here. So 2, 1, negative 20, and 21. All right, let's use it. Bring the 2 down. Multiply 3 halves times 2 is 3. Add them up. 4. 3 halves times 4 is 6. Add them up. That's negative 14. 3 halves times 14. Negative 14 is negative 21. And look at that. 0. So this shows you that that one is a 0 of the function. So x minus 3 halves is a factor. But technically, if we keep doing that, we're going to get x minus 3 halves, x minus this, but really we should be getting a 2 somewhere. Right? So far we have x plus 2 as a factor, x minus 3 halves as a factor, and when we use those two, we got this factor left. So I wrote that down here. So I'm going to write out my factors right now. I'm going to put x minus 3 halves right here. And I'm going to put x plus 2, which was the first one we found. Okay, so then that makes sense. X times 2x squared gives me 2x to the 4th. But look at this. We don't want this right here. Look at these 3 terms. Do you notice anything? You notice that 2 is common in all 3 terms. So what I'm going to do is I'm going to pull that 2 out. 2 times x squared plus 2x minus 7. And then I'm still going to have x minus 3 halves and x plus 2. That looks ugly though, right? Because it's times 2. So what I'm going to do here is I'm going to take this 2 and I'm going to multiply it to this thing right here. So if I multiply 2 times this, that becomes 2x, and 2 times this, that becomes minus 3. So basically, in all reality, when you get the fractions, it's really, you take that denominator out front and then it's 2x minus 3. That was the real factor. Okay, so final factors are x plus 2, 2x minus 3, because I distributed that 2 here, which I don't distribute to everything, just that one section, and then you got x squared plus 2x minus 7. Now look at those. Those are 3 factors that we got based on looking at the calculator. I looked at the calculator, got this one. I divided, and you got this thing, which is the other factor. I looked at that factor. Actually, I should have typed that in the calculator. We looked back at the original. I should have typed this in the calculator and then look for another 0, which you still would have come up with if you did second calculate. You would have come up with this is a 0. Okay, so if this is a 0 of this, then you use synthetic division and you come up with your other factor. Okay. Alright, now you got your last factor, you pull out the 2, there it was, and then you rewrite everything. So these 3 factors multiply to get this guy up here. Still not done yet, right? What are we looking for? We are looking for, should have wrote up top, find all the zeros. Okay? That's great. Find all the zeros. And to do that, those are the steps, but we're still not done. So 0 right here is negative 2. You can tell just by looking at it. A 0 right here is, move that 3 over, divide by 2. 0 is 3 halves. We already found that out. That's a 0. That's a 0. Now how are you going to get the 0 of this thing right here? Well, some of you are probably thinking, well, what if that factors? Factors is negative 7 that add up to 2. This thing does not factor. That's why I chose this problem. Okay? So how are you going to find the zeros of that right there? Well, the only way right now is quadratic formula. Okay, so let's end off the problem with quadratic formula. Negative b, which is 2, plus or minus square root of b squared, so 2 squared, which is 4, minus 4, oh goodness, a, which is 1, times c, which is negative 7. Okay? All over 2 times a, which is 1. All I got to do now is simplify what you see up here. I'm going to go up instead of down. So negative 2 plus or minus square root of, what does that become? 4 plus 28, so 32 all over 2. And lastly, you have to simplify this. I don't want decimal answers. None of these in this thing are decimal answers. You just simplify. Square root of 32, you should know that. Square root of what? 4. Square root of 8, which keeps simplifying. So square root of 16 and square root of 2. So that's 4 root 2. So here's what you have so far. Negative 2 plus or minus 4 root 2 all over 2, but you better know that simplifies, right? 2 and 2, 4 and 2, so this becomes, last answer, negative 1, divide, plus or minus, 4 divided by 2 is 2, root 2. That is your final 2 answers. Now look at all the answers that you have. I know this is kind of messy. I'll write it in purple here. Final answers. You found negative 2 in the beginning, you write it down. The next one you found was 3 halves, you write it down. And then the next 2 you had to use quadratic formula on, and which you come up with up here. Negative 1 plus or minus 2 root 2. And that is the basics of solving, finding the zeros of any long polynomial. Okay? Step 1, look in your table if there is any. And sometimes there won't be any. If there isn't any, you just go straight to step 2. Second, calculate. Calculate some zeros. That's how we got to 3 halves. Okay? Right from your calculator, right? So I'm just doing a recap right now. So second, calculate. You can do your zeros. I'm not going to do it again. Left boundary, right boundary. Find them. Okay? Sometimes the answers are weird answers. That's why you got this answer right here, 1.828. Okay? You don't round. That's just an irrational answer, so you can't go with it. That's this right here. 1.828 is one of these 2 answers right here. Negative 1 plus or minus 2 root 2. That's where that came from. Okay? So you have to do it all by hand here. So if there's any questions, you guys got to come see me. You got to practice this. All right? Go along with the book. Read the book. That's about all we can do, though. That's the gist of today's lesson. Just follow the steps, and yeah, just come up with all the zeros. Notice the degrees 4. That's why we come up with 4 answers. So, okay, guys, this will be your practice problem. This is all I want to do from this section. Just know those steps in finding all the zeros. So take several minutes. It's going to take a little while to find all the zeros of this function step by step. Okay? Good. Pause the video and take your time to do that. I'm going to put up the answer. Alright. I'm just going to kind of go through a slide, pinpoint some things. Step 1 is to list all the possible rational zeros. Why do we do this? Why do we list all the possible rational zeros? Because let's look at step 2, looking at the graph. Okay, you see these. Let me get my pen here. Here's a 0. Here's 1. Here's 1. And here's 1. What we could do is we can narrow that whole big list to just a few. You know, this is like 1, 2. This is 2 point something. So look back at your list and say which one of those is about 2 point something. Well, maybe that's the 12/5 one. Okay, could be. We don't know. Look at this one. It's in between 0 and 1, so that can be 0.6 around there. So look in my list, my big long list, there was 3/5. So that point right there could be 3/5. Look over here. That's about halfway in between. So I think that should have been negative 1/2. And then this last one is like 1 point something past halfway, so right around halfway. Negative 3/2. That's where they come up with these 4 values. Basically, we're just kind of cutting down our list into what we think it could be, what the reasonable answers could be. Okay? So you could, what I would do is I would calculate each one. So I would calculate that one and see what I'd get. I would calculate this one, see what I get. And some of those answers, they're going to be weird decimals, which means those are irrational numbers. You can't get the answer from that. So you got to go to the next zero, until you get a nice fraction one, like 3/5 is 0.6 or 12/5 is 2.4, something like that. Okay, but when you get a big long decimal, it's irrational, which means you can't use it. Okay, so next, what the book does is they test those things. So we narrowed it down to 4 things it could be. 1, 2, 3, 4. So we test each of those. That's what they're doing. So they test negative 3/2, and look what happens. The remainder is not 0, which means negative 3/2 is not a 0 of the function. So negative 3/2 is out of the picture. So then I go to another one, negative 1/2. Okay, and if you use synthetic division, it is a 0. So since that's a 0, that means x minus r, which is x plus 1/2, is a factor. Okay, but you could have got another factor by now. It has a few, so that might not have been the one you got, and that's okay. But as long as you keep working at it. Okay, so if that's a factor, if x plus 1/2 is a factor, here is the other factor. Now, what do you notice about these numbers right here? I mean, it means 10x to the, what is this, third power, minus 16x squared, minus 34x plus 24. They're all divisible by 2, right? That's why this factor isn't really x plus 1/2. If we factor out a 2 out of all this, 5x cubed minus 8x squared minus 17x plus 12. And then the factor of x plus 1/2 down here, I'll just put it down here. But then what we would do is take that 2 and we would distribute it, and our new factor would be 2x plus 2 times 1/2 is 1. So our new factor is 2x plus 1. Notice the shortcut, I can just kind of take that 2 and put it out front here. So there's a factor, and here's my new factor. Okay, so these two multiply to get the original on the first slide. Now, what you want to do is you want to take this new factor and you want to kind of like start over. Okay, so find zeros of that new factor. Okay, so type that in your calculator. If you didn't do that, I would type that in your calculator and I would try to find some more zeros. You're not you're not going to find any nice ones in the table. So you're going to have to work for it. So go hit second calculate and find another 0, okay, of this. When you do that, let's see, step 4. So this is what I did just a minute ago. Pulled out the 2, and this is what we have so far. So what you want to do is you want to take this new factor and then find the zeros of it. Type it in and look for some zeros. Now what they do is they do step 1 again, which I did tell you to do, but it's not like you have to do this step, but they found all the possibilities again, so we can narrow down our list by the graph. Okay, so then we type it in and we go to the graph, which they don't show it, but the graph shows, they just tell you in words, the graph shows that 3/5 could be a 0. Now what they do is, so if it could be, that's why they would do 3/5 here, and they would do that on this guy right here, and in the end it will show that 3/5 is a 0 if you did the work. Okay, so if 3/5 is a 0, then you're going to have some things left over. So let's get there. So far what do we have? From the calculator, the first 0 we got was what? 1 negative a half. So far we got negative 1/2 is a 0. Next, we use that, we got this, and then we find a 0 of this to be 3/5. So far we got negative 1/2 and 3/5. You have to figure out what you have left over. So hopefully the next slide shows this, and it does right here. You would have left this. So just let me do this real quick. 3/5 in the box. Over here should be 5x cubed minus 8x squared minus 17x plus 12. So 5 multiply, you get 3, you get negative 5. You add, or multiply, you get negative 3. Then you get negative 20, and you multiply and you get negative 12, which you'll notice the 0 here, which means 3/5 is a 0, which means x minus 3/5 is a factor. And then so they pulled that factor out. That factor times this guy right here gives you this up here. Okay, so but notice, what do you notice about that thing? They're all divisible by 5, so they're going to pull that 5 out, right? And then multiply it to this, which then you get 5x minus 3, and then x squared minus x minus 4. Okay, almost done. Now, here's your other factor. So far your zeros are negative 1/2, and this would give you the zeros of positive 3/5. We're looking for a couple more zeros, so that's where this comes into play. First thing I look for, does it factor? Factors are negative 4, they add up to negative 1, and it does not factor. So therefore you have to use the quadratic formula, and I'm not going to go through that. I'm going to assume that you can use quadratic formula on this guy right here. Okay, well, I guess it'll show you quadratic formula. Step 6, find the remaining zeros by quadratic formula. There it is. And there is your answers for the last quadratic. Put all your answers together. We got this from the calculator. We got a new polynomial, which then we got this from the calculator. And then we did synthetic again, and that's where these two come from after we did the quadratic formula. So that's how you find the zeros of a polynomial. You guys got questions, you know where to find me. Okay, you have a good day, and I will see you soon.